My name is Gabe Monroy. I am the CTO at Deis. I was an early Docker contributor, very early Kubernetes user, mediocre Go programmer, lots of things. I spend actually most of my time in the field working with customers who are working at the bleeding edge of containers and distributed systems, microservice architectures, and I really like to try and find folks who are willing to cut themselves real bad so that I can then supply the Band-Aids, right? That's kind of, or bandages, as it were. So that's kind of what I do. What's interesting is this talk is billed as Steward, a project that we kicked off at Deis a while ago. And what's interesting to me is that at the time that I submitted this talk, we were building Steward, and since then, it turned out that the open source community has sort of converged on a solution that was solving the same problem, which is basically the service catalog implementation that some of you folks may have seen earlier today. We've actually sort of merged efforts with that. I'll talk a little bit about how that came about, but I do think it's sort of fascinating to know that in the time between submitting this talk and coming here and giving it, the open source community has sort of converged on a direction, and this work has really started to rocket towards a very interesting place in my view. So where do we start here? I think this is kind of an abstract concept, right? Service catalog, service broker technology. It feels a little abstract. And I think to root the discussion, it's important to talk about what problem this is solving. And it turns out service catalog is actually solving multiple problems, but let's just focus on one for a minute. So no application is an island, right? We can all agree with this. Applications have to talk to databases, queues, lots of different things that applications need, outside of their ecosystem. And I think in the container microservice space, we've sort of been sold this false premise that everything we do from an application standpoint, the other apps and services that we're going to talk to, it's going to be provided to us in an ocean of containers, right? So there's going to be all these containers, databases are going to run in containers, queues run in containers, all your sort of durable stuff's going to run in containers. And I think that's not really how this is playing out to date, and I also don't think it's how it's going to play out as we move forward. And the reason for that is pretty straightforward. The reality of most IT environments is that they're heterogeneous. They're siloed, right? So you have container clusters, right? Kubernetes running over here. You have, cloud provider stuff, right? RDS or equivalents, running in the cloud. You have the database in the back of the closet. You have the machine under some guy's desk, right? All of that forms a company's IT infrastructure, right? And solutions that only deal in the container portion of that are only solving part of the problem, and we're not interested in solving part of the problem. We need to solve all of it, and I think service broker and sort of the service catalog technology allows us to do that. So today's solution, and it was funny, I talk about note passing in the session earlier today. They actually physically were passing notes to each other to sort of demonstrate this. But you think about today how this works when you're writing an application that depends on another service or another application. What happens today is that someone, typically in operations, will grant you access to a database service. They will provide you coordinates like host and port, username, password, maybe something like a logical database name, and they will write that on a note or send that to you over Slack or some other medium, and that will be your mechanism for retrieving your credentials. Now, that's not great. Right, but it's what we have. It's what we're doing today. Everyone is doing that, right? And forget about what happens when you need to rotate credentials or when the service gets deprecated. I mean, you get a lot of problems with this sort of model, but in general, it works today, and people are happy. But the issue with this is that if you have N applications with N other services that they need to get connected to, you end up with an N squared problem, a proliferation of these notes effectively that are getting passed. And if you think about this, the only record right now of the fact that my app is connected to that database is in the config that I injected into that app, which is typically tracked maybe in a manifest somewhere. But if I wanted to go figure out who are all the consumers of that database, there's nowhere for me to go. Right? Maybe I could look at network traffic to implicitly figure out who's connected to something, but that's not a great solution. So the problem today, the one I'm most interested in, is how do we manage interconnects between all of these different applications, application to application, application to service, application to cloud provider service. I mean, lots of different interconnects that we need to be worried about. This is a big problem today. And so I think there's actually two answers to this. The first is the introduction of a service catalog. And the service catalog is the place where you take everything in your environment, heterogeneous IT environment, and you put it into the catalog. I'm talking your database services, all your applications, literally anything that your app might ever need to talk to should eventually live inside this catalog, right? Once you have a catalog in place of what you have from an IT perspective, then you can move on to the second phase of this, which is explicit bindings. And this is really important. Going forward, I think today, what's happening is implicit binding, right? So if your application can find the other application via service discovery, via coordinates that were injected, via username and password that happens to work against that service, boom, you made a connection, right? You're bound to that service sort of implicitly. That's not great, right? What we need in the future is we're going to need explicit binding to allow hooks for things like policy. So for example, if my application needs to talk to a database server, I should be able to, for example, open up the SDN to allow for network communication flows to happen over a default deny network policy, right? Explicit binding allows for that. Another example is dependency graph, right? If you have all of these services connected explicitly and these bindings are tracked in a database somewhere, you can actually query that database and draw a pretty nice picture of what your current sort of service topology looks like in terms of dependent services. So when you go to deprecate a service or do credential rotation on a service, you know what the downstream impacts of changes like that are. So if you can do these two things, introduce the service catalog, promote this concept of explicit bindings, you can hopefully bring some sense of order to the chaos that we're currently dealing with regard to sort of this note passing model that's so prevalent in IT operations today. So this brought the Deis team to Steward. The idea here is looking after passengers on the good ship Kubernetes. And we started, as we do at Deis with early prototypes, trying to get at the problem, trying to feel what sort of solutions looked right. We started off with some third-party resource stuff. It was pretty interesting. But the goals of this were to, threefold. First was to make it easy to expose and consume services, right? If this stuff isn't easy to use, it won't matter, right? We can build the coolest thing ever, but if developers can't actually wrap their head around it, then it's not going to make a difference to folks. So that was goal number one. The second goal, I think this is more interesting, and I'm actually going to show this in the demo later on, is we want to decouple provider from consumer. The ideal for me is, as a developer, I want to be able to think in terms of, I have a database, or I need access to a database, specify my intent. But I don't necessarily care how that intent gets fulfilled, right? I don't need to say, I want a very specific version of Postgres running in containers, or I want RDS, fulfilling my Postgres. That should actually be left up to operators who are in charge of, a given environment. And that would allow you to, for example, have different ways to fulfill the Postgres database in dev versus staging versus production, right? As the developer, you want the intent, you don't care about how. And so decoupling provider from consumer is one of the main goals that we had for this. And the next thing was, I was hinting at this before, we want to enforce this idea of an explicit dependency graph. Explicit in the sense that it's tracked and sort of versioned, ideally inside of Kubernetes, but also that's policy driven. So, if, for example, you're only allowed to, access databases with this many IOPS, or you're not allowed to provision this super expensive cloud provider service without getting permission first, we want to enforce some operational constraints on what people are able to do with something like a catalog. So, turns out that there was a group of us cowboys who were working on this problem. It was mainly ourselves, Red Hat, Google, and IBM, have sort of formed the core of this group who are operating right now under the SIG service catalog. And it just so happens that what we were doing with Steward aligned with some efforts that Google was pursuing internally inside Google, and Red Hat was thinking deeply about the problem, and we actually all got together for a face-to-face at the Deis offices in Boulder, and we sort of started designing this thing as as a team, as a group of disparate vendors who share common goals. And that's really interesting, and I think a fascinating kind of part of the story here. And what ended up happening is that the Steward project, you still find it on GitHub if you're interested, but we thought it made more sense for us to actually merge efforts with the SIG, we decided that the SIG sort of implementation was something that we could contribute to effectively. It met our goals, and we really wanted this to be a community effort from the outset, and we were frankly quite pleased with the way the SIG was being run, and with the progress that we were making, despite it being pretty difficult to do things like design by committee, in the context of something like a SIG. We were actually able to make that work against all odds, I would call it. So at a super, super high level, how does this work? It's really, to my mind, 3 steps. So the first is you're going to install the magical service catalog. And I'll show you what this looks like in a bit, but the service catalog right now is sort of a separate API surface that is implementing a Kubernetes-like API with its own controller. You install that into the Kubernetes cluster. That's step number 1. Step number 2 is you're going to launch a series of brokers, and these are actually, Cloud Foundry, now Open Service Broker API compatible brokers. And this is how you populate the catalog, right? Part of the broker specification is a way to fetch and enumerate what services are, being provided and brokered via that broker. Those get populated into what are called service classes inside of Kubernetes, and those service classes are then available to, developers to consume via manifests. And the third step is to do that, consume this stuff. And there's 2 objects here that you are concerned with as sort of on the consumer side. The first is an instance. So I, for example, want an instance of Postgres, or I want an instance of RabbitMQ. And specifying that in a manifest that references a service class that is, was populated by one of those brokers, that's how you can basically provision dynamically an instance of any one of the services that are in the catalog. Those, by the way, could be a microservice. It doesn't have to be something like a data store. And then the most important part on the consumer side is actually the binding. The binding it says, I want to connect to this instance, and I want you to give me the credentials and the coordinates and everything that I need via either secrets, config map, volumes, whatever the sort of output of that binding looks like. And I want that injected into my application dynamically, right? I don't want to think about it. And you saw that in the demo earlier today. I'm going to show you another version of that demo. And this is the model, right? Install service catalog, launch some brokers, and start consuming stuff via manifests. So with that, let's jump right into a demo here. So the first thing I'm going to do is I am going to drop into a Helm list. So just to set the stage here, I'm going to deal in terms of Helm packages here because it's just easier to work through the flows that way. All of this stuff can be done with kubectl raw. I will sort of go into some of the manifests, but I think it's important to talk through sort of the interaction model here. So first thing I want to show you is what this looks like today, roughly, right? So today, actually, sorry, first what I want to do is I want to show you an application. Let me browse to this application. This is Deis S3 Uploader. And so what this is a very, very simple Go application that is going to upload a file to S3. And what it does, if we take a look at the charts for this thing, take a look at the templates and the job. Inside of the container spec here, we have 3 fields in the environment. We have the access key ID, we have the secret, and we have an S3 bucket name. This is the interface for the application. This is what it expects in terms of credentials, right? So let's keep that in mind as we work through the demo. So the first way to do this is to think of this the way we do this today. You go to ops, you ask for a bucket, they give you the bucket name on a piece of paper, they add create an IAM role for you, they give the access key and the secret key, and you sort of inject that into the application using, in this case, a set or some other environment injection, secret injection, typically out of band. And if we hit enter, we can see that this will get installed. And what it's going to do is it's going to populate a secret, which includes those credentials. And it's going to create a batch job here. And if we go and we query in the steward namespace, get pods, we can see here that we have a manual S3 consumer job that completed. So if we take a look at the logs of this thing, we can see this thing worked. It uploaded to GabberTV-bucket, uploaded a file. If we go into the S3 console here and hit refresh, I can see GabberTV-bucket. I can see test.jpg. Open it up. And that's not a knife. This is a knife. Lachlan Everson on the Deis team built this thing. So he's from Australia, if you didn't guess that. So that's sort of the manual phase of this. But that really stinks, right? We had to go through this process. We had to manually inject these credentials. What if there's another way? So if we took a look inside of the next thing I'm going to show you here, which is the template for the instance, you can see that actually, you know what, let me just install it and I'll show you the post-rendered version of that. So we're going to do this again. But in this case, I'm not going to specify any credentials. Instead, I'm going to bundle into my package a binding and an instance. And if I do a helm get on S3 consumer, we can take a look at what that got templated out to. You can see the instance here references this service class AWS S3 plan name default. So if I get service class name steward, you can see this AWS S3 item in our catalog. That's effectively what this is. We output it to YAML. You can see a little more here what this looks like. So we see the really long, this is actually, I think, an icon that's provided by this broker. And we can see the default plan, which is basically a single S3 storage, unlimited bucket, unlimited number of objects. That's basically what this broker is providing. So if we take a look at the output of this thing, oops. We can see the S3 consumer. Nice thing about jobs, the first one errored out because the secret wasn't actually mounted yet. The controller had to run for a minute to actually mount the secret, so the job restarted until it got one successful completion. That's why we use jobs, folks. And take a look at the output of this thing, and we can see the same thing happened here. However, this time you'll notice that there is a cf-gwid bucket name. So if we jump into S3, we can see that there is a cf-gwid bucket with the same file inside of it here, right? So same exact application. We didn't modify the app at all. But what we were able to do is using the service catalog, the S3 service, AWS-S3 service class, and by specifying an instance and a binding, and actually let's take a look at the binding real quick, binding-n steward. Take a look at the binding here. You can see that we reference the S3 consumer instance, which is the, the bucket is effectively. And we provided it with a secret name. This is a where do you put the results of the binding. This is going to evolve as, there are plans currently in the service catalog to sort of leverage new features in Kubernetes like, what used to be called pod injection policy, now is called pod preset, correct, thank you. So there's going to be more flexibility. It won't just be secrets. You'll be able to do secrets, config maps, volumes, lots of different things that can be preset into the pod specs. But you can also see the status condition here. Inject bind result is true, right? So you can see that this thing actually completed end to end and finished that. And if we actually go grab this secret and output this to YAML, you can see that the name, password, username, this is actually what got consumed by the application. So this is demonstrating basically the automated provisioning and binding and eliminating sort of this note passing. And this is, I think, incredibly cool. And this is, when I talked about that first goal of making it easier to consume and produce services, this is the future. This is what we're going to be doing in a year, right? There's another thing I want to show you here, which is decoupling provider from consumer, right? I want flexibility as an operator to do different things, to fulfill the service requests in different ways in different environments. So what we're going to do here is I'm actually going to go and install a different broker. I'm going to install a Minio broker. How many here are familiar with Minio, the Minio project? Okay, I love this group. Minio S3 compatible storage system. I happen to have one pre-seeded on my cluster. The cluster I'm demoing right now is actually an ACS cluster, because it just happened to be the last one I spun up, running on Azure, and I'm connecting to S3 right now to do this demo. Not ideal, right? As an operator, that's not what I want, but the developer did it that way. So let's fix that, right? So instead what I'm going to do is I'm going to take the Minio that I already have installed on this local cluster that's actually co-located with the workload, and I'm going to load this broker. And what this actually did here is it installed a basically off-the-shelf open service broker API for Minio. Very, very simple to crank one of these out. It basically says, it has 3 endpoints. Give me the catalog, what sort of services do you offer? What does it mean when you provision one of these things? How do I get a new instance effectively? And what does it mean to bind to one of these things? What are the coordinates you need to inject? That's all you got to do for these brokers. They're incredibly easy to crank out, and there's some future plans we have in that direction. But now if I query this thing, if I get service class in the namespace Steward, I can see, oh, look at that. We got Minio now added as a new service class. So as a developer, what I can do is I want to run that job again, but I'm actually going to run the Minio consumer job, which actually is the same exact application, same exact workload. But what we did here was we changed the instance and the binding to reference that Minio. So if we take a look at the Minio consumer template, we can see that we changed the instance here. Actually, sorry, helm get Minio consumer. Come on. So we can see here that we're looking at the binding. Here's the instance. So we can say the service class name is Minio. The plan name is the default plan for Minio, which is the same thing. And the binding here references that Minio consumer instance, and we're injecting it to Minio consumer secret, right? So now if I take a look at this this job, I can see the Minio consumer. Oops. We can see the logs here. We can see this uploaded again using a very similar cf-gwid name. And if I jump over here into my Minio browser and hit refresh, you can see I've got my bucket here with my file. And if I grab a link to this thing, that's a knife. So we've managed to decouple provider from consumer without modifying the application at all. We were able to swap the implementation of the backing service. We've also, per the previous example, been able to radically simplify what the experience looks like for developers who want to consume these services and do it in a way that's actually secure, right? No more note passing. And I think that there's a big future here in being able to query these binding objects. If get steward binding output to YAML, by iterating over all of the bindings in the system, you have all of the data that you need to draw a dependency graph. So you can envision a future where every single application you wrote, even the ones you were writing in-house, you basically made it the contract of the developers that, yeah, you're going to ship software, but you're also going to publish that software to the catalog. And when you publish it to the catalog, we're going to be able to open up the SDN on the fly, we're going to be able to track bindings, and we're going to be able to draw dependency graphs for people. Folks are getting at this problem in similar ways with things like service meshes, but the problem with that is those aren't generally very policy-driven. This is a much, much more sort of explicit and frankly secure. So I'm pretty excited about the future of this. So couple more slides, and then hopefully have some time for questions here. So, want to be clear, this is all under construction, heavily under construction. There's a few things I want to point out that are specifically related to that construction. The first is aggregated API. So, interestingly, this is one of the first projects I've been involved in, or really known about generally, that is extending the Kubernetes API significantly enough that you can't do it with third-party resources. This really breaks TPRs. And actually, we knew that firsthand because the first versions of Steward used TPRs, and we realized it was just not going to be sufficient for something that had this many different types of resources. And what happens when you delete a broker and that cascading deletes instances, and it's just really, really tricky to model that inside of TPR. Unfortunately, aggregated API is not what I would call fully baked yet. It's getting there. I think the future for this thing is bright, but until the Kubernetes clients can actually discover all these aggregated API endpoints and sort of amalgamate all that into one presentable control plane surface, it's weird to use this. You can install it. There's a walkthrough in the service catalog repo where you can go run through a very similar demo to this. You can take it for a spin, but it's not yet what I would call something that's ready for prime time here. The next thing is SDK. So we talk about this future where people are brokering up all their services, and I really think that having an SDK to make it easy to fill in a few methods and get effectively the ability to write a broker with just a few function calls implemented, that's the future that we need to be in, and that's something that the SIG is going to be taking on. I have no doubt. And the last thing I want to point out is I actually think that there's an opportunity here to create a higher level consumer API. The thing I'm interested in is I don't, as a developer, necessarily want to worry about instance and binding as first class. I think we can wrap an abstraction on top of that basically is working at the service protocol and service version level. So, I want Postgres greater than or equal to 9.4. Right? And that should be the intent that I specify. And then that can compile down into instances and bindings. But we need to really think that through because it requires consistent naming, right? What does Postgres mean, right? What does greater than or equal to 9.4 mean across different environments? If we can get all the folks that are currently involved in the SIG to collaborate on that, as well as the communities like Cloud Foundry and some of the other folks that are working with this, I think we have a real opportunity to sort of homogenize a namespace and make it just an order of magnitude easier for developers to consume this stuff across different platforms, Kubernetes and well beyond. But there's still some work to do here. And I think the point of this is, we're at the point now with the service catalog where we have working code, we have demos, there's a lot of excitement around the work that's happening here. We really need voices of the user community now, and specifically of operators. A lot of this comes down to what are the interaction models that operators are going to want for this stuff going forward. And we'd love to have your voices in the SIG, so we definitely appreciate it. Everything we do in the SIG is open. We publish the videos. People actually watch the videos, which is just amazing to me. But we definitely love your participation, so feel free to jump in. So with that, thank you. So it looks like we got a few minutes for questions here. Fire away. Yes, in the front.
Brokers, you create brokers as bolts, or you're I would imagine if I would like to create my own broker, which will manage my virtual resource, how would I do that? Should I use broker SDK and run the broker as a container?
So the brokers will run in the cluster. Sorry, the question was how do you create and manage sort of brokers going forward, because it's a critical part of this process. So there are off-the-shelf ones for common services, but if you want a broker to your own applications, you're going to have to write one. And today, fortunately, the API for this is not very complicated. In fact, one of the folks on the Deis team whipped up the Minio broker in about a day for me, so to help with this demo. So thank you, Matt, by the way. So it's not that hard to write these. However, I do think an SDK is warranted, and I think that's something that we'll probably end up tackling in the SIG, is my guess. The broker is going to be, enumerate the plans for this thing, Redis, small, medium, large, right? What those mean in terms of parameters to things like the provision calls, and then what the provision call looks like, right? So how do you provision a Redis, small, medium, or large? And then the third is binding. When someone binds to Redis, what does that mean? Right, and how do you return those credentials and those coordinates back to the consumer, right? So it's really three methods more or less that you're filling out here. So not that hard to do. Next, yep.
So the binding is currently only concerned with secrets, but if you
Yes, well, the question is config maps and more granularity around what you can inject. That's absolutely the goal. Secrets was the easy thing for us to kind of knock out and demo, but having that as the only thing that you can inject, that's not great. I mean, there are futures future brokers that we're thinking through that involve mounting, volumes, right, where you could actually broker to a volume service and actually get a volume injected. So pod presets, if you haven't looked up those, they just landed in 1.6. Check out the docs. Actually, on my Twitter account, I actually have a link to the docs, Gabber TV on Twitter. You can check that out. But pod presets are going to allow you to make sort of policy-driven changes to pod specs that will be a better way of fulfilling what that secret field is doing in the binding right now. So it'd be functionally equivalent, but more flexible. Yes?
Let's assume you create a service like MongoDB instance, for example, and do you also then have the ability to upgrade version or increase the volume or something like this, so second-day operations?
That's a good question. So the question is around day 2 operations for some of these brokers, and what does that look like? So the Open Service Broker API has the concept of a plan change, and you can make so if you provision a Redis small and you need to go to a Redis large, there is an API call for that. I don't quite know how that works today. I would envision that you would change the plan name in the spec for the instance from small to large, and we would make that intent we would sort of reconcile that intent and upgrade the thing for you. Obviously, the services themselves have to be supportive of that, and that's not always clear. So I think it's a fine line. I think the thing we're most concerned about is making sure that the API design is right, and punting the problem of what does it mean to upgrade a service like that to the service provider and operator. Other questions? I'm sorry, what was
How do you see about the declaration of the relationships between services or applications? Are you thinking on anything on this?
How do we see declaring relationships between services and applications? So, yeah, so the concept of a binding, assuming you have done the work to make it easy to craft brokers, and assuming that you make brokers part of the contract for shipping an application, which is a future we can get to, I think, if we make it easy and make the SDK sort of plug and play, right? Which is something we can do. Then you basically have bindings that you can query and draw relationships between instances, and that can sort of allow you to draw that idea of a dependency graph. I think this combined with service mesh creates a really powerful solution. I think the interesting thing about this approach is that by having a provision call explicitly performed, you can do things like open up SDN or do policy checks at the last minute that are just not something we see with service meshes in the wild. Other questions? Yes?
Is there a timeline for this? An expected release date?
There is a timeline for this. I don't know what the expected release date is here, but Paul Morey in the back, he's kind of hard to find, but if you look closely for the pink mohawk, you might be able to pull him out. He is, him along with Aaron Schlesinger, who's the lead from the Deis team here, who's up in the front, can talk about kind of what the schedule looks like for this thing. It is early, but we are moving aggressive. And due to all the demand that we're seeing from folks like yourselves, we're going to be under even more pressure to get this thing out soon because people really want it. So fast is my answer. That said, I think it won't be until Kubernetes 1.7 that the aggregated API story hardens enough where I would recommend putting this into anything resembling production. All right. Thanks, everyone. I'll be available for questions if you have more.